Welcome to part 3 of our lecture on exception handling in C#. In this section, we'll address two vital topics. First, how to handle exceptions in file and directory operations, where failures can be frequent and costly. Second, how to use the throw statement to raise and rethrow exceptions, including wrapping exceptions with added context. Let's begin with file I/O, one of the most common sources of runtime errors in real-world applications. File and directory operations often fail. The file may not exist, permissions may be missing, or the path may be invalid. If we don't handle these cases, the program crashes or causes data loss. Proper exception handling prevents this by giving us safe fallback behavior and ensures stability and reliability. Here are some common exceptions under System.io. I/O exception, base class for I/O errors, file not found exception. The file does not exist, directory not found exception, folder is missing, unauthorized access exception, no permission, path too long exception, file path exceeds the limit, end of stream exception, reading past end of file. Knowing these helps you write specific and useful catch blocks. In this example, we try to read a non-existent file. The first catch block handles file not found exception, printing a clear message. The second block catches general I/O exception, covering other file-related errors. This layered approach ensures that we respond precisely, but still have a fallback. Here we use a stream reader to read a file, wrapping it in a try block and using the using keyword ensures. If the file can't be read, the exception is caught. The file is always closed even if an error occurs. This pattern is both safe and efficient. This example shows how to write to a file using StreamWriter. We handle unauthorized access exception for permission issues, I/O exception for general problems. Again, the using block ensures that the file stream is closed properly, avoiding leaks. Here we try to list files from a non-existent directory. A directory not found exception is caught and handled. Without this, the program would crash. This is especially important when scanning file systems dynamically. When working with files, always use try-catch finally. Prefer using to release resources automatically. Catch specific exceptions first. Avoid hard-coded paths. Use path.combine. Always check if the file or directory exists before accessing it. I/O exceptions protect your application from failures related to files, folders, and disk operations. These errors are common, and without exception handling, they can cause user frustration and data loss. I/O exception is the parent of all file-related exceptions. It occurs when a file can't be opened, read, or written. Other exceptions like file not found exception and directory not found exception inherit from this class. These are subclasses of I/O exception, directory not found exception, end of stream exception, file not found exception, file load exception, path too long exception. Each provides more detail about the type of I/O failure. This code demonstrates how to handle different I/O exceptions with specificity. Try to read a file if it's missing. File not found exception. If directory is wrong, directory not found exception. If anything else fails, I/O exception. This pattern improves debuggability and user messaging. Best practices. Use try-catch finally. Catch specific exceptions first. Use I/O exception as a general fallback. Log everything for diagnostics. Never hardcode file paths. Always build them dynamically. This final file I/O example reinforces the using pattern. It ensures that the stream reader is automatically disposed even if an exception is thrown. It's cleaner than writing your own finally and reduces risk of memory leaks. Now that we've seen how to protect file operations, let's look at how exceptions are thrown and how to rethrow them when necessary. This allows us to build structured, layered exception handling logic in real-world applications. Throwing exceptions lets us report problems as soon as they occur. Instead of letting a method fail silently, we throw a meaningful exception. This delegates the responsibility to a higher-level component that knows how to handle it. Here's a method, validate number. If the input is negative, it throws an argument exception. This is how you enforce rules and guard against invalid data. In this example, validate number is called in a try block. If the method throws an exception, we catch it and display a friendly message. This illustrates where to throw and where to catch. Sometimes, a method catches an exception but can't fully resolve it. In this case, we log the error and rethrow it using throw. This preserves the stack trace and allows higher layers to respond appropriately. This example shows a method that catches and logs an exception. It then uses throw to pass it up unchanged. This is useful when you need to record the error but not suppress it. You can also wrap an exception with additional context, for example, catching a lower-level error and throwing a new application exception while preserving the original as inner exception. This helps add semantic meaning and traceability. Gate guidelines. Only throw for exceptional conditions, not control flow. Use throw to rethrow without losing stack trace. Use throw new exception MSG inner when adding context. Always handle exceptions at the appropriate layer. Don't catch everything too early. The throw statement raises an exception object. It must be of type exception or a subclass. Example, throw new exception, something went wrong. Here's a simple example. Method throw exception raises a new exception. If it's called without a catch block, the application will crash. This shows how powerful and dangerous throw can be if not handled correctly. Key behavior of throw inside try. The rest of the try block is skipped. Control moves to the first matching catch. The finally block always executes if present. This flow makes exception handling predictable and consistent. In this part, we explored two critical dimensions of exception handling. First, how to work safely with files and directories using proper catch blocks and resource cleanup. Second, how to raise and rethrow exceptions to build flexible, layered error handling systems. These patterns help you write code that is not just functional, but reliable, maintainable, and production ready. In the final part of this lecture, we'll look at unhandled exceptions, global exception handlers, and how to structure exception flows across large applications.